Okay, we're going to combine both the Gutermuth method and the Koenig method into one movie chapter here. So both of these methods are using color, and color magnitude diagrams to find young stars. So Gutermuth's method, which is what we're going to cover first, uses Spitzer and 2-mass data. It requires 4 bands of IRAC, which don't exist everywhere in the sky. Even within a given star-forming region, for particular objects, you might not have all 4 bands of IRAC. So you may or may not be able to do this for a given object or a given region. This approach basically looks like this. For each combination of colors, you can compare colors for each one of the objects. You basically make a plot, either physically yourself or just metaphorically within the computer. For each object, you note the properties of that object in that plot in comparison with where other objects fall. Then, for each one of those objects, you end up with a big table with one entry per object that have the properties of each object in each combination that you've checked. Then, based on those ensemble properties, you can make an educated guess based on all of those properties and all of those bands, which ones are the young stars. So, all of the steps look like this. The first part is drop things that meet all of these criteria. So 4.5 minus 5.8 less than this. 4.5 minus 5.8 less than that, and 5.8 minus 8 greater than 1. So 4.5 minus 5.8 versus 5.8 minus 8. Drop the x's, because things that meet these criteria are galaxies with PAH, polycyclic aromatic hydrocarbon, PAH emission. So drop those things, because they're more likely to be galaxies than they are young stars. Okay, next step. Drop things that meet all 3 of these criteria. Things that meet these criteria are also galaxies with PAH emission, these guys. Drop things that meet all of these criteria and these guys out here. These things that meet these criteria are active galactic nuclei, galaxies. Drop things that meet all 3 of these criteria. Things that meet these criteria are likely unresolved blobs of dust, in other words, things that look like point sources but really aren't, whose colors are dominated by shock emission. Okay? Keep things that meet all of these criteria and don't fail the earlier tests. Things that meet these criteria are likely class 2s. Keep sources are likely protostars if they have an extremely red color. In addition, any sources with a moderately red color that also have this are likely protostars, although in rare cases, a red and class 2 source could have these colors. Things that meet these criteria are likely class 0s or 1s. Keep going. In his paper, he's got this all spelled out. So we've just got all of this. He's doing extinction corrections, then he's doing this, and then having done the prior 2 steps, add these things back in, add objects that meet this, add this, and then go back and check. So for the Gutermuth method, many famous clusters have already been observed with Spitzer and thus have already had this kind of analysis done. Many other clusters in the galactic plane and thus have serendipitous Spitzer data. And if you have a cluster that's in the right place to have all 4 bands of serendipitous Spitzer data, you're golden for this method. But a lot of the galactic plane has only 2 bands of IRAC, just IRAC 1 and 2, and then you can't use this method because you only have 2 bands of IRAC. 2-mass can provide JH and K, but deeper observations in 2-mass are super helpful, and there are a couple of surveys that provide that, at least in some regions. So Xavier Koenig's method was inspired by Gutermuth's method, and this one uses both Ys and 2-mass bands. He's also published a follow-up study where he did spectroscopy of the things he identified as young stars to try to see how successful he was at identifying young stars, and he found about an 80% success rate given his method. So for this approach, again, you compare colors for each object, you know properties of that object, and you have a big table with properties of each object in each combination, and then you make an educated guess. Here, we've got 3.6 minus 3.4 minus 4.6 versus 4.6 minus 12. Those lines are various models. The dots are points, objects in a region that's likely to be all galaxies. And he's looking at where these objects fall. And are they all really galaxies? It turns out that, yeah, they probably are. And so now he's looking at a catalog of known young stars. Where do the objects fall? So the colored dots are Taurus stars, known young stars. How did they compare to the galaxies? So he drew a line around this clump and said anything that's in this clump is more likely to be a galaxy than a young star. So then just keep going in all the combinations he felt was worthwhile. So again, the colored dots are the known young stars. The dashed lines are the things that he was excluding as more likely to be not young stars. And then he's looking at the patterns of the object type. Here's 3.4 minus 4.6 versus 4.6 minus 12. These are the class 1s and 0s. These are the class 2s. And these are the class 3s. Again, drawing lines in diagrams. Trying to identify types of objects in various parameters. So the IRAC data are more sensitive and higher spatial resolution than Ys, and so they should, in general, give better results than Ys. But we need to look at the Ys data and see where the Ys data makes sense to use. It may only make sense in some cases for some clusters, especially when you have lots and lots of sources packed in there tightly. It's harder to use Ys. We don't have the full-up machinery that Koenig has, but we can attempt it. And we absolutely have to inspect images. We cannot just accept the catalog blindly because Ys does get confused. Winston, in 2020, Winston et al. Had a big survey in which they were trying to use all of the GLIMPS and Ys data to identify young stars. And they're also doing color cuts. She's basing her approach on both Gutermuth and Koenig, but she's adjusting some of the cuts depending on what she thinks is the right thing to do. She was trying to do it over a huge chunk of sky. So she's not doing the detailed, careful analysis that NITARP teams typically do on each individual target. So I can tell from the stuff that we've checked that she's got a bunch of sources in her catalogs that are probably not point sources. They're probably nebular knots. So we know that because we checked images. And so this is why we need to check the images. So main takeaway points. Cuts in one diagram can work for finding objects, but cuts in more than one diagram work even better to help you separate the wheat from the chaff. None of the cuts are perfect. They are all involving statements like, this is more likely than that to be a young star. And you can see that even in the diagrams, right? You can see that there are young stars falling in regions of galaxies and galaxies falling in regions of young stars. The more information you have, though, the better a guess you can make.